Here's one more example of a definite integral that involves u substitution. This is a trig example. I'm going to let u be equal to pi t. Right? We don't know how to deal with those angles when they're more complicated than just the variable letter. That's going to make du equal to pi dt. And since I don't see a pi there anywhere, that says that 1 over pi du is going to be equal to dt. We also need to replace our limits of integration. So u of 1/4 is going to be pi times 1/4, or pi over 4. And u of a negative 1/4 is going to be negative pi over 4. So rewriting our definite integral gives us the 1 over pi times the integral from negative pi over 4 to positive pi over 4 secant squared of u du. Right, the pi t got replaced by the u. The dt got replaced by the 1 over pi in front and the du, and then we replaced our lower and upper limits of integration appropriately. So the antiderivative here, we're going to end up with 1 over pi times the tangent of u evaluated from negative pi over 4 to positive pi over 4. So that's going to give us 1 over pi times the tangent of pi over 4 minus 1 over pi times the tangent of negative pi over 4. Now the tangent of pi over 4 is 1, so we're going to end up with 1 over pi. The tangent of negative pi over 4 is going to be negative 1, so we're going to end up adding 1 over pi. And it looks like we should end up with 2 over pi when we're done here. Now if you try to check that on your calculator, you'll want to note the fact that 2 divided by pi is about 0.6366. So on your calculator it'll give you a decimal back to check things. I like exact answers, but to make sure you're right, you should get about 0.6366.